All right, so where we left off, we got done solving for this wire right here. This wire is completely done through that equation. Now, what we're going to do is we're going to solve for the voltage difference. Solve for the current, because what we're trying to do is we're trying to solve for all the currents and make them equal zero right now, right? So what we're going to do now is we're going to find the current across this resistor, right? We're going to find the current, because there's three different currents, just to let you know. There's three different currents in this circuit. There's a current here, there's a current here, and there's a current here. So we have three separate series circuits in our essentially in our which face in our circuit. So now what we're gonna do is we're gonna find the voltage difference. I mean, not the voltage difference, my fault. We're gonna find the current on this wire right here, right? That's what we're gonna do. So, oh, did I mess up something? I think I did. All right, here we go. So what we're gonna do is we're gonna label our points. As we know, VA is our high potential in this case. So let's do that. We're gonna do VA, the high potential, and we're gonna have 0 volts as our low potential, because we we are theorizing that all the current is going towards VA, right? And in order for all the current to go towards VA, that means that VA has to be the high potential, right? So that's why VA is the high potential, just so you guys know that. So what we're gonna do now, how do we find the current across this resistor? Well, we can look at our equation right here. It says the voltage difference across the resistor, which is going to be high potential minus low potential, which is VA minus 0, right? So the voltage difference across that resistor divided by the resistance of the wire here is going to equal the current of the wire. So let's write that equation real quick. So let's add to this. So we're going to do our high potential, V, which is VA, minus the low potential, which is going to be 0 volts, right? And we're going to divide that by the resistance on the wire, which I believe is 5 ohms, right? And we're going to add that to our next equation, right? That is correct. Yep. So this wire. So now we have completed this wire, and we have completed this wire. Right? We completed both wires. So let's finish our final wire. So let's look where the electricity is going to travel. So it's going to travel through the negative terminal of the battery to the positive terminal, which is going to be a voltage lift of 12 volts, right? So we got 12 volts here. 12 volts is going to stop at this resistor, right? It's going to stop at this resistor. And now we have to use Ohm's law, right? So let's do that real quick. I don't know why this thing is messing up. All right. So we're going to do that real quick. So let's do Ohm's law. So, as we know, in order to find the current across this resistor, we have to do the voltage difference, right? A high and low potential. And as we know, electricity, we travel from the negative terminal, right? So that means the electricity is going this way. So that means VA is the high point, right? That's the high potential. So we're going to label it that. So VA is going to be the high potential. All right. If I can put it in a good place. All right. And 12 volts is going to be the low potential here. All right. So, and we know to get our voltage difference, we got to do high potential minus low potential. So let's write that real quick. High potential. So we're going to do VA minus 12 volts, right? And we're going to divide that by the resistance of this wire, which is 2 ohms, if I'm not mistaken. And all of this, so we've completed all the wires, right? So there's no more wires left. So all of that should be equal to 0. All of that is going to equal 0, right? Let me see if I can move this over a bit just so it's not in the way. All right, here we go. So all of that is going to be equal to 0, right? So now what we can do is we can just solve, right? So we're just going to use basic algebra to solve this. So let me make another part of this. All right. Label this 2.0. Here we go. Oops. Did not mean to do that, but oh well. All right. So let's label that. And here we go. We're going to start solving. All right. So let's solve for VA real quick. So again, this is just a giant equation. So we're going to do an equation, right? Oops. And I did not put R1 in value. So let me do that real quick because I messed up there. R1 is going to be 10 ohms That is completely my fault. Sorry, guys. All right. So let's start solving, right? So we're going to have VA divided by 10, VA divided by 5, and VA divided by 2, right? So if we know anything about fractions, and we want to, and as you can see, everything is being added together in this equation, right? Everything's being added together. So if we want to add fractions together, right, we gotta find we gotta have the same denominator, right? So let's find the least common multiple of all of these, right? Which is going to be 10, right? Because 5 can go into 10, 10 can go into 10, and 2 can go into 10, right? So we're going to do 5 times 2, 5 times 2, 5 times 2. I mean, my bad, 2 times 5, 5 times 2, and 10 times 1, right? And we're going to add all of those together that we had on the side together, right? So we're going to have plus 5, plus 2, and plus 1, which is going to give us 8 over 10, right? And we can simplify 8 over 10. So let me do that real quick. We can simplify 8 over 10 into what? Uh, 4 over 5. Yeah. So VA is equal to 4 over 5. Now, if you have no idea what I just did there, um, you're probably gonna have to brush up on your algebra rules. But yeah, I guess I can just write out what I just did right there. So just to help you guys out. Actually, no, I'm not gonna do that. That's gonna take too much time. And that's not what this video is focused on. So yeah, we got VA. So we solved for VA, right? We solved for VA. So let's see what we got now. So we're gonna have, so we have 20, 0, and 12, right? So 20 is gonna be divided by 10, which is gonna be 2, negative 2. 0 is gonna be divided by 5, which is just gonna be 0. Negative 12 is gonna be divided by 2, which is gonna be negative 6. So if we add 2 and negative 6, negative 2 and negative 6, we're gonna get negative 8. Now we can put that on the other side of the equation, right? And we can get positive 8, right? We can get positive 8. And yeah, VA equals 4 over 5 divided by 4 over 5, and that equals 8. So now we can simplify this again and get our answer. So let's do that real quick. Let's simplify that again. I guess I'll label this 3.0. Right. I guess I could have did it on the same thing. Oh well. Anyways, so this is gonna be our answer. So let me do shift enter. So we're gonna do algebraic rules, right? And we're gonna do 5 over 4, right? 5 over 4 we're gonna multiply this by 5 over 4, right? Because 5 over 4 times 4 over 5 is gonna equal 1. So we're gonna have 1 on that side. We're gonna isolate the VA, and then we're gonna multiply 5 over 4 right here. So we're gonna have 8 times 5, which is 40. So we're gonna have 40 over 4, and 40 can go, yeah. So we'll have 10. So VA should equal 10. VA equals positive 10. Now, if you guys want to brush up on your algebra rules or like understand how I got that, you can click on my Discord and I can teach and I can show you guys like how to do like fractions and stuff. So like if you want to ask me like how to do that, you can through my Discord. And my Discord is in, not only is it in my YouTube bio, but it's also in the description of this video. So if you guys want help with that, I can help you with that if you contact me on Discord. So we think VA equals 10, right? That's what we think VA equals. So let's see if that's actually true. So we are going to run a simulation. We're going to say 1. All right, here we go. Okay. And yep, VA is equal to 10. We did our math correctly. And that is our first nodal analysis problem that we have completed. All right.